The U.S. Department of Energy confirmed it. Lawrence Berkeley National Laboratory tested it. And a 4,000-year-old solution, a powder so cheap it costs less than a cup of coffee per square foot, can slash your cooling bill by up to 60%. But here's the part that should make you stop scrolling. The air conditioning industry in America is worth $120 billion a year. And in 17 states, the building codes, the same codes quietly written with industry input, make this powder either impossible to use legally or completely invisible in energy efficiency programs that could put money back in your pocket. This is not a conspiracy theory. This is a paper trail. If you want to understand why affordable solutions vanish while expensive ones get mandated, subscribe right now. Because what looks like a story about rooftop powder is actually a story about who owns your thermostat. This is not really a story about powder. It is a story about how three invisible forces, energy economics, lobbying money, and building code manipulation, work together to make sure the cheapest solution never becomes the default one. The question was never whether this material works. Researchers settled that decades ago. The real question is why a solution this affordable, this proven, and this old is still treated like a fringe idea in the world's wealthiest country. The answer runs straight through utility boardrooms, state legislatures, and a roofing industry that earns $56 billion a year, replacing roofs that, with this powder, would last 15 years longer. That is the system we are pulling apart today. And once you see it, you will recognize it everywhere. Today we are going deep into the science, the history, and the economics behind reflective, cool roof technology, the category this powder belongs to. By the end, you will not just know what it is. You will know exactly which industries are spending money to keep it out of your building code. You will know why the hottest states in America have the weakest cool roof standards, and you will understand the one number, $38 billion, that explains everything. Let us get into it. People were already using whitewashed mineral coatings on rooftops in Mesopotamia and ancient Egypt, not for aesthetics, but for survival. Pale, reflective surfaces kept structures cooler without a single watt of electricity. That knowledge is over 4,000 years old. In 2010, researchers at Lawrence Berkeley National Laboratory published findings confirming that modern cool roof coatings, primarily calcium carbonate and titanium dioxide-based compounds, reduce peak cooling demand by 10 to 15%. A follow-up Stanford study in 2012 modeled global adoption and found the carbon offset equivalent to removing 300 million cars from the road for 20 years. Meanwhile, the U.S. HVAC industry grew to over $120 billion annually. The cool roof coating market, despite all that evidence, sits at just $5.8 billion globally, a fraction. The gap between what works and what gets adopted is not an accident. This channel exists to explain exactly that gap. Picture a flat rooftop in Phoenix, Arizona on a July afternoon. The surface temperature of a standard dark roof hits 170 degrees Fahrenheit. That heat radiates downward, forcing the air conditioning system inside to run almost continuously. The homeowner pays for every degree of that battle. Now take calcium carbonate, a mineral compound so common it is used in chalk, toothpaste, and antacid tablets. Grind it into a fine powder, mix it into a roof coating, and apply it. That same rooftop surface drops below 100 degrees Fahrenheit. The cooling load on the building falls by up to 40%. The material cost for an average single-family home between $40 and $120 total. The average American household spends $525 per year on cooling alone, according to the U.S. Energy Information Administration. The payback period for a cool roof coating is under 2 years. After that, every summer is cheaper, and yet fewer than 10% of U.S. residential rooftops have any form of reflective coating. You have probably spent more than $1,500 on cooling bills over the past 3 summers. A one-time $80 application could have changed that math permanently. The barrier is not access. The barrier is awareness. And awareness has been economically managed. The technology is not the problem. The problem is that somewhere between the laboratory and your rooftop, a financial interest made sure the path stayed complicated. Would you coat your roof for $80 if it cut your cooling bill in half? Keep that question in mind as the numbers get harder to ignore. NASA uses the same reflective physics to protect spacecraft from solar radiation. The International Space Station's thermal control system is built on the principle that reflective surfaces reject heat rather than absorb it. That is not experimental. That is aerospace engineering standard. And yet the average American school building, sitting under the same sun, uses a dark membrane roof that absorbs heat all day and pushes cooling costs onto school district budgets that are already stretched. The International Energy Agency reports that cooling accounts for 10% of all electricity consumed globally. By 2050, that figure is projected to triple as temperatures rise and middle-class populations in hot climates grow. The IEA describes this as one of the most critical and under-discussed energy challenges of the next 30 years. India understood this faster than the United States. After a 2010 heat wave killed over 1,300 people in Ahmedabad, city officials launched a cool roof program. The material cost per household was under $15. Within 2 summers, heat-related mortality dropped by 30%. The European Union has included cool surface mandates in its Green Deal framework for new construction by 2027. Australia updated its National Construction Code to include cool roof requirements in 2022. The United States, as of 2026, still has no federal mandate, and in 17 states, the baseline energy codes have not been updated since before 2015, meaning the standards governing your roof were written when the iPhone 6 was new. When science is settled and adoption is still slow, the next question is never technical. It is always financial. Here is what most energy explainers skip entirely. Building codes in the United States are not written by scientists. They are shaped by industry working groups, trade associations, and contractor lobbying bodies. And the most powerful one in this space has a 5-decade history of influencing the rules that govern your home. The International Energy Conservation Code sets the national baseline, but each state chooses whether to adopt it, modify it, or ignore it entirely. In 17 states, reflective roofing standards are either absent, frozen at outdated pre-2015 versions, or actively weakened by local contractor licensing frameworks that create compliance barriers for non-traditional materials. The Air Conditioning Contractors of America operates in 48 states. Between 2020 and 2024, the broader HVAC and building systems industry directed over $47 million into state and federal political contributions. The overlap between states with the strongest HVAC lobbying presence and states with the weakest cool roof standards is not a coincidence. It is a map. Every household that installs a cool roof coating represents between $800 and $1,200 in lost HVAC service and replacement revenue over 5 years. Multiply that by millions of households and the financial motivation to keep those standards complicated becomes very clear. The same states with the most brutal summer heat, Texas, Florida, Louisiana, Arizona, are among the states where cool roof mandates face the most resistance. The people sweating the most are living under the codes written by the industries that profit from their discomfort. Does it surprise you that the rules governing your roof were shaped by the industry that sells you the machine to cool what the roof heats up? There is a term economists use for a situation where the person who would benefit from an improvement is not the person who has to pay for it. It is called the split incentive problem, and nowhere is it more damaging than in rental housing. Renters make up 36% of all U.S. households. They live in the building. They pay the electricity bill, but they cannot legally modify the rooftop. That decision belongs to the landlord, who pays nothing toward cooling costs and therefore has zero financial motivation to invest in a cool roof coating. The Rocky Mountain Institute documented this split incentive problem extensively. Low-income renters in urban heat islands, neighborhoods where dense dark surfaces trap heat and push temperatures 7 to 10 degrees higher than surrounding areas, face the steepest cooling bills and have the least power to change the conditions causing them. A targeted federal subsidy program for renter-occupied cool roof installation has been proposed in Congress 3 separate times since 2015. Each time it failed to advance past committee. The lobbying dollars spent against it are public record. Meanwhile, the renters most affected continue paying premium electricity rates in states where utility pricing structures reward high consumption. A family in Houston renting a second-floor apartment under a black membrane roof pays more to stay cool in August than a family in Stockholm pays to heat their home through winter. That is not an energy problem. That is a policy choice. And policy choices have authors. Here's the piece of this story that reframes everything else. Your electric utility company, in most U.S. states, operates under what regulators call a rate of return model. Under this structure, utilities are permitted to earn a guaranteed profit margin on the infrastructure they build and operate, and that profit is calculated as a percentage of their total costs. The more electricity consumed, the more infrastructure justified, the more revenue approved. This means that when your home runs cooler without electricity, your utility company's approved revenue base shrinks. Reduced consumption is not just inconvenient for utilities. In states with traditional rate of return regulation, it is structurally unprofitable. The U.S. residential electricity market generates $230 billion annually. Cooling accounts for roughly 17% of that, approximately $39 billion per year, flowing from residential customers to utility companies just to manage indoor temperature. The Energy Information Administration has modeled that nationwide cool roof adoption at scale could reduce residential cooling electricity demand by $38 billion annually. That $38 billion is not abstract savings, it is current utility revenue. And utility companies employ some of the most sophisticated regulatory and lobbying operations in American government. They do not file that revenue away without a fight. Every degree your home stays cooler without drawing electricity is a degree your utility did not get paid for. The system was not designed to make that easy. Would you switch energy providers if one actively supported affordable cooling solutions? The answer matters, because consumer pressure is one of the few forces that moves faster than a lobbying budget. You have now seen the full shape of this. A proven material, a $120 billion industry, 17 states with frozen building codes, $47 million in lobbying, and a utility sector with a structural financial interest in keeping your home warm. The next section is the part most videos never reach, and it is where the real cost of all this lands. If this kind of analysis is useful to you, hit subscribe and drop a like right now. Not for the algorithm, because the next video in this series will make this one look like the introduction. You do not want to miss it. The insurance industry knows something the building code lobby does not want widely discussed. Heat damage to roofing materials costs U.S. insurers $3.1 billion every year in accelerated degradation, structural claims, and premature replacement coverage. Oak Ridge National Laboratory published findings in 2019 confirming that cool roof coatings extend roof lifespan by 10 to 15 years by reducing the thermal expansion and contraction that cracks and warps conventional roofing materials over time. The actuarial case for cool roofs is airtight. A roof that lasts 30 years instead of 15 generates fewer claims, lower payouts, and better loss ratios. 4 major U.S. insurers currently offer premium discounts for certified cool roofs. 4 out of hundreds. The reason more do not is partly inertia, but it is also pressure from the $56 billion U.S. roofing contractor industry, which earns its revenue from installation and replacement jobs. A roof that lasts twice as long as a customer who calls twice as rarely. That is a direct threat to service volume, so the insurance industry sits on data that would accelerate cool roof adoption. The roofing contractor lobby applies quiet pressure against premium incentives that would drive consumer demand for longer-lasting roofs. And homeowners, caught between the two, keep replacing roofs every 15 years, paying full price for a shortened lifespan that was entirely preventable. This is not a technology gap. It is a revenue protection arrangement that spans 3 industries simultaneously. There is a cost that does not appear on any energy bill, but shows up everywhere else. In hospital admissions, lost work days, school closures, and infrastructure failures during heat events. Economists call it the social cost of heat. And in the United States, it runs over $100 billion every year. Urban heat islands make this worse. Cities are measurably hotter than surrounding rural areas, sometimes by 7 to 10 degrees Fahrenheit, because concrete, asphalt, and dark rooftops absorb solar radiation all day and radiate it back through the night. Residents of dense urban neighborhoods never fully escape the heat their built environment is generating. Lawrence Berkeley National Laboratory modeled what widespread cool roof adoption across U.S. cities would produce. The conclusion: average urban temperatures would fall by 1.5 degrees Fahrenheit. That may sound minor, but at the city scale, 1.5 degrees means measurably lower peak electricity demand. reduced ground-level ozone formation, fewer heat-related emergency room visits, and higher outdoor worker productivity. The Natural Resources Defense Council estimated in 2021 that capturing those benefits nationally would generate $11 billion in annual economic value, reduced healthcare costs, productivity gains, and energy savings combined. None of that $11 billion appears in the cost-benefit models used to justify current building codes. The models that determine whether a regulation passes or fails are built on direct material costs and direct energy savings. The broader social value, the hospital beds not filled, the workers not collapsing on job sites, is left out of the equation entirely. When you build a model that ignores the costs borne by the public while counting the revenues earned by the industry, the model will always favor the industry. That is not economics, that is accounting with a preferred outcome. There is a feedback loop built into this system that almost nobody talks about, and once you see it, the $38 billion figure from earlier becomes even more significant. When cool roofs lower urban temperatures by 1.5 degrees, air conditioning demand falls further. Lower demand means less electricity consumed. Less electricity consumed means less heat generated by power plants feeding the grid. Less waste heat from power plants means slightly cooler surrounding air temperatures. Cooler air temperatures mean even less air conditioning demand. This is called a negative feedback loop, a self-reinforcing cycle that works for consumers rather than against them. Every step reduces the next step's cost. It compounds in the direction of affordability. The U.S. electricity grid currently wastes approximately 65% of the energy it generates as heat before it reaches your outlet. A meaningful portion of that waste heat contributes directly to the urban heat island effect. Cool roofs interrupt the demand side of that cycle. The system as currently designed runs the opposite loop. Hot rooftops increase cooling demand. Higher demand increases grid load. Higher grid load justifies infrastructure investment. Infrastructure investment earns utilities their rate of return profit. Profit funds lobbying. Lobbying protects the building codes that keep rooftops dark, round and round. The technology to break that loop costs $2 per pound and has been available since ancient Mesopotamia. The economics protecting the loop are worth $120 billion a year. That is the only reason you are only hearing about this now. Whether it is cool roof powder, generic drug suppression, or public transit underfunding, the pattern is the same. Affordable solutions exist. The science is not in dispute. The barrier is never technology. The barrier is that somewhere in the chain between laboratory and living room, a revenue stream is threatened, and revenue streams that large do not go quietly. They go to state legislatures. They go to building code committees. They go to the utility commissions that set your electricity rate. The decisions being made in those rooms today will determine your energy costs for the next 30 years. The $2 powder works. It has always worked. The question was never whether it works. The only question is, who loses money the day you find out? If this video changed how you see your energy bill, subscribe. Every week on World Economics Explained, we follow the money behind the systems that shape what you pay, what you eat, where you live, and what choices you actually have. No filler, no vague takeaways, just the economic forces most channels never connect for you. The next video will make you question something you have trusted your entire life. Subscribe so you do not miss it, and share this one with someone still paying full price for a problem that has a $2 solution.